I'm going to leave you with two important tips at the end of this talk. The faster you understand, the easier it is for you to get a quicker solution. Through this video, I am going to answer a very commonly asked question on our channel, and I hope this video was engaging and you will learn something from it. My message to you this morning is, if you like to learn well enough, probably it is the time that you start trying something new. So get back to doing something. Try something different. These were all the hit and trials and definitely your solution ahead. And let's begin with the today's topic, that is mathematical induction. And using mathematical induction, we have to prove the statement for all n belongs to capital N. That is 1 plus 3 by 1 into 1 plus 5 by 4 into 1 plus 7 by 9 plus and so on 1 plus 2n plus 1 by n square is equal to n plus 1 whole square. So here there is no addition in between these two brackets. See, observe, there is a multiplication. And next we have to use mathematical induction, and nth term is also given. So here the nth term is given as 1 plus 2n plus 1 by n square. And this is the LHS part and this is the RHS part. And let S of n be the statement. See here, S of n with the statement. The question itself is the statement. In the mathematical induction, the process is, in the step 1, we have to prove that it is true for n is equal to 1. So we have to take n is equal to 1 in the LHS and RHS. What is the LHS part? So this is the left hand side, that is 1 plus 3 by 1, which is equal to 1 by 3, which is equal to 4. And next one, the RHS part is n plus 1 whole square. So in this, if you keep n is equal to 1, this will be 1 plus 1 whole square, 2 square, which is again equal to 4. So we got both the values as same as 4 for LHS as well as RHS. So for LHS is equal to RHS, we say that S of 1 is equal to true. The statement is true when n is equal to 1. So this is the first process, the step 1 we have to consider. And in the step 2, what we have to assume? So in the step 2, we have to assume that S of k is true. So which means that in the statement, we have to keep n is equal to k. So this is the statement. Throughout the statement, in this, if you keep n is equal to k here, so wherever you find n, you keep n k here. So there is n here, I kept k, and there is n, keep k, and there is n here, this is k here. So here you consider this equation as equation 1. And in the step 3, now we have to show that S of k is true. So we have to show that. So when in the statement, if you keep n is equal to k plus 1, so we have to show it is true. So here nth term is nothing but, so here is the nth term, that is 1 plus 2n plus 1 by n square is the nth term. So I'm calculating k plus 1th term. So in place of n, I'm writing k plus 1. So what is the answer here? This is 2k plus 2 plus 1 by k plus 1 whole square. So which is equal to 2k plus 3 by k plus 1 whole square. Now in this case, we have to multiply k plus 1th term on both sides of the equation 1. So what is equation 1? Equation 1 is nothing but, after keeping n is equal to k, so this is the equation 1. So we have to multiply both sides. So in our previous questions, we added both sides, the k plus 1th term. And now in between these two brackets, there is a multiplication, and therefore the k plus 1th term is also multiplied on both sides of the equation 1. So here in this step, so this is equation number 1. So as this is equation 1, see here, now we have multiplied this one. So in this, we have to keep, so after keeping n is equal to k, so this will be the k plus 1th term, and in this we have to multiply the k plus 1th term on both sides. So this will be the k plus 1th term after keeping n is equal to k. See, clear? And now see here, we have to check, or we have to prove that it is true for n is equal to k plus 1. For that, I am considering this RHS part, right hand side part. So here it is very clear that this is k plus 1 whole square, and if I take k plus 1 as an LCM, so this will be k plus 1 whole square plus this is 2k plus 3. And if I cancel these two and see what happens here, so this will be a square plus b square plus 2ab plus 2k plus 3. Clear? And this will be k square. And if you observe, this is 2k plus 2k. So this will be 4k. This will be 4k plus, and if you see, this is 1 plus 3. So 1 plus 3 is nothing but 4. And this can be written as, so this can be written as, this is a square, and this is 2a into b, and this is again b square. So this is of the form a square plus 2ab plus b square. So which is equal to a plus b whole square. So if you observe the RHS part, the nth term will be, so what is the nth term? So what is the RHS of this equation? That is n plus 1 whole square. So here is n plus 1 whole square. So if you adjust this one as k plus 1 whole square. So in place of n, we have k plus 1. So in place of n we have k plus 1. Therefore, so if you observe this one, so this is the first term, second term, third term, kth term, k plus 1th term, and here this is the RHS part, and after multiplying and after doing all the process, so we got this equation as k plus 1 whole square, which is nothing but the RHS part in the given statement. So S of k plus 1 is satisfied. See here, this is the RHS part of the given statement, and this RHS part of the given statement is replaced by n is equal to k plus 1. Therefore, S of k plus 1 is true. So if the given statement is true for n is equal to 1, 2, 3, k plus 1, it is true for every natural number, and therefore our question here is, that is 1 plus, this is 3 by 1, into 1 plus, this is 5 by 4, 1 plus, this is 7 by 9, plus and so on. 1 plus, this is 2n plus 1 by n square value is equal to, this is n plus 1 whole square. So this is according to the mathematical induction. This is true. And thank you so much for watching and staying till the end, as this is of a different kind, as the k plus 1th term is multiplied on the either side, both sides of the equation 1, as this is the point which you have to keep in mind. And if you really like, what to do, please raise your thumb, pass it on to your friends, subscribe to this channel, stay connected. And if you really like, what to do, please leave a comment below, and so that I'll be posting all the solutions for your given questions. And thank you so much for watching.